Hello and welcome to the presentation for the Game and Interactive Media Development course. My name is Lars S. Peter. I'm the founder of the course, and I want to talk a little bit about what we do in the course, what the career options and chances are, and how we get the students towards their career start in the field of game technology and interactive media. I want to answer a couple of questions and go over a couple of topics in this presentation. The first one is, what is game technology? What am I actually talking about? And what can you expect from it? Then, what are the career options and why are they there? What do we teach and how do we teach it? And how does it all culminate at the end of the year in our students starting their career? So, game technology is a rather broad term. It combines a couple of different technology aspects, and the four main ones are 3D modeling and 3D graphics. You might know the term already from movie effects, Avatar, all the new Star Wars movies, the Marvel movies, all of those since the Jurassic Park dinosaurs in the 1990s have used 3D models, computer-generated images, to create realistic objects that are not really real. We talk about the virtual world quite a lot, and the three-dimensional virtual world needs 3D modeling. 3D modeling can also be found in architecture and in beautifully rendered art, and today even in the medical field and 3D printing. Every car part on your car has been designed and planned in a 3D modeling tool before it actually got to the manufacturing plant. So we use these 3D modeling tools and 3D models for our virtual worlds and for many other purposes, but mainly to create architecture for our levels, 3D characters and environments that you see nowhere else on the planet. In most cases, they're not even on this planet. Okay, so the other one is digital design or graphics design. In the broadest sense, creating 2D imagery, bitmaps for user interfaces, for 2D games, like think of Angry Birds, but also creating mock-up screens for concept art, creating mock-up art for our game concept and game design documents, and many other things. Programming is one very important pillar that a lot of people automatically shy away from because they think it has to do a lot with mathematical approaches and analytical thinking, which could not be further from the truth. It helps to have those skills, but they're not really necessary until you're going really deep into simulations. Programming languages are more like learning a language that can help you tell the computer to do what you expect it to do under certain conditions in the game. Player input, objects touching each other, somebody typing text in, things like that. Programming is the essential tool for that, and it's actually quite easy to learn. I learned it, and I always say, like, if I can learn programming because I'm not an analytical thinker, then everybody else can. So it's like learning a new language that basically is a magic language that makes things happen because hardware responds to it. And then we have the game engines, which are pretty much our main tool when it comes to creating the final app, the final, what we call the build, that we then can distribute online, on DVDs or wherever, in order to have users experience the interactive app or the game or whatever you want to create with this technology. In a game engine, everything comes together. In a virtual 3-dimensional, 2-dimensional world, we add the sound in, we make the sound work through programming, and the 3D models work and correspond with each other with programming. The 2D textures come in, and every designer does his or her part in order to create the game in the end. And then we can develop and publish this for augmented reality, virtual reality games, mobile games, and in whichever form we need it. So those are the 4 main pillars of game technology. And this is a very versatile technology. A lot of people automatically assume that when you are trained in the field of game technology and the tools that it uses, you have to automatically work in the field of game development, which couldn't be further from the truth again. Game development is part of it, and a very interesting and entertaining part, because you are an entertainer. You create these games to entertain people. But in other areas and other industries, this technology has found a very strong foothold, and a lot of industries are now embracing this technology for various reasons. So if you specialize in game technology, you're not limited to game development. You have a lot of industries that you can pick from in order, when it comes to starting your career. You can start in an architect studio creating virtual spaces that do not exist yet, but you make them interactive because this is game technology. I will go through a couple of examples to show you how vast the career options really are. Game technology enables us to create virtual reality worlds. This is one of our students from last year working on her virtual reality art project that she created as her final project. So she delved into surrealism, researched surrealism as an art form, and created it as an interactive virtual reality experience. So you're pretty much in the virtual painting, the virtual surrealist painting. This is just one application of this technology. She uses the same tools that another student would use to create a mobile game, but she chose to use it for a VR headset to create a VR experience. Now, VR experiences are used in many other fields as well. For instance, in architecture, so you can walk through a building that doesn't exist yet and can change wall textures and move furniture around if we program it that way. Or you can train a surgeon on a virtual body about the first steps of surgery. So there are many different applications for that. Another huge technology that uses game technology and the skills that are involved is augmented reality. This is a photo of one of our students from last year again. She created an educational game for kids about geometric shapes and how they go from a flat surface to let's say a square to a cube, or from a circle to a cylinder, and create this app in a way. She created this app in a way that it's fun to learn and very interactive, so it sticks with the students much better. The educational field is incredibly interested in this technology because they see a lot of benefits in augmented reality as a tool to make learning much easier and more entertaining and spark that interest. Now, she could have done this as an augmented reality app. Augmented reality basically adds virtual content to the real world, while virtual reality removes the real world and puts you into an entirely virtual and different world. With virtual reality, we can she could have done this as a project for an architect, where you have a 3D model of the future building on a table. Or it could be an instructional app that shows you how to remove parts of your motor in order to exchange the spark plugs, even though you have no idea about how a motor works. These applications are already out there, and they can be done with the right tools and the right planning, and this is what we train our students in. Using the tools for whatever purpose they want the apps they create to achieve. Mobile games, yeah, you saw augmented reality on a mobile device. We can also create entire games on a mobile platform. That has different benefits. A lot of these games are very successful. It's a huge market, and we can use these games for entertainment. We can turn again something into a more educational purpose. There are so-called serious games that train adults and managers in certain topics. We have these typical brain trainers like Elevate. All of these apps are created using the same skill sets, just for a different purpose. And this wide range of application is why a lot of different industries are embracing this technology by now and are really interested in hiring expert trained in the skills and the tools needed. There are movie and TV productions that now use this technology to plan their productions, to create 3D prints of sets, to create 3D prints of accessories for actors. Some of the digital effects you see are actually done in game engines now, and not with supercomputers rendering for days. Architects are very interested in this because all of a sudden what they used to have cardboard models for are now interactive, photorealistic looking versions of the buildings they want to build for their clients. And the clients can actually walk through them if they use them in virtual reality. The urban planning is also interested in that. You can lay out an entire city and then simulate crowds moving through it and how crowds would respond to specific changes in this flow of streets or obstacles being in the way and architectural differences. The medical field is looking into this because all of a sudden virtual reality training is an option. Augmented reality can help with analyzing and looking at certain aspects of therapy. The medical field also uses 3D imagery. An MRI scan is a 3D version of anything that you scan. We can use this data, those zeros and ones, and turn it into a 3D printed model that you can touch and inspect. Or we can put this 3D model into a virtual reality app and share it with someone halfway across the planet in a matter of seconds, because it's data that we can send over the internet. The educational field I already mentioned, and advertising, for instance, is also very interested. Imagine an augmented reality app that shows you the interactive 3D model of a car on the cover of a car magazine, just as one example. So there are many applications that are super interesting outside the ever-growing game development field and industry, but it is up to the students to decide which way they want to go. Maybe they want to do work for architects first, and later on they go and develop games. That is totally an option. Just one hint there, what I encourage people to think about is not what the job situation is right now and the jobs that are here right now, but what new jobs might pop up in 5 years, 10 years, 20 years from now, because students that start now will be in the job for at least that long, hopefully. And there might be an option that nobody thinks about today, but it needs these skills, which is why the Academy of Digital Arts teaches not for a specific job. Those days are over. You do not get an education to train for a specific job. That job might not be around in 5 years' time by now. We train for skills, and then you pick the job that is available, or the jobs that are available where these skills are needed. This is our approach. So how do we get you there? The course is our typical 1-year higher certificate accredited full-time course. And in the first 4 months, we teach our students all the basics that are needed in the different modules that we have. I'll go over them in just a minute. Learning the basics in all fields is very important, because you need to have the basic understanding of all the disciplines that are involved in game technology and using game technology, even though you will specialize in one field later on. Because game and interactive media development is always a teamwork where different specialists combine their skills to create the end product. You have to be able to work in a team and have to be able to understand what the other guys are talking about and why they need your work in a specific way. I compare it always to a movie director. If a movie director does not have any idea of how a camera works and what camera angles can do to change the atmosphere in a specific scene, how he needs or she needs to instruct actors, and how communication works, if they do not know what lighting can do and what a lighting specialist needs to know, what a set designer can do, they will never be a good team worker that can give the instructions and give the information that all these specialists need, that help the director to make his or her vision come to life. So there's a career that is over before it actually started. This is why we teach the basics in the first 4 months, and then our students specialize. And the specialization then culminates in the final exam project, where they show the level of skill that they have in general and within their specialization. Our 4 main modules are game theory, game graphics, game programming, and game technology. Game theory deals with the mechanics of games on a theoretical level, what makes a game or an interactive app fun, entertaining, how does it achieve its purpose, what do we need to know about the target group, what does the target group mean for the design in terms of graphics and language and whatnot. And then also game theory involves production planning, research, and we teach another set of so-called soft skills through other projects. I'll get back to that later. Game graphics deals with visual language, creating 3D models, creating 2D graphics, user interface design, and all that. Game programming, as I mentioned before, teaches our students how to use the language of C# to program everything in our game engine that we need the game to understand and do. And then game technology is the understanding of how these game engines work, what we need in terms of graphics, how 3D models work, and how everything comes together, and how we use that to create a virtual reality mobile game, an augmented reality app, and the other things that we can do with this technology. Our projects and our student work also has a strong emphasis on teamwork for obvious reasons. As I mentioned earlier, the students need to learn time management, manage their own time, manage a team. They learn about work ethics, handling clients, and dealing with deadlines. And that is very, very important. I'll get back to that later again. So our modules have individual projects, depending on what exercises we're doing right now. They do teamwork projects. This all is there they have to hand in the projects. It's practical work. We have 30% theory, 70% applying the knowledge learned in theory through projects. This is the best way of learning this and honing your skills. And it helps building the portfolio towards the end of the year. It also generates work experience. They learn how to work in a team while they're here. They learn what happens if you make mistakes and that you learn from mistakes. They learn how to communicate in a team, why meetings are important, and whether or not a meeting should be short and sweet or a little bit longer. This whole soft skill development is an essential part of all of our courses. And the feedback that we get from employers that have our alumni students pretty much proves that that is the right way to do it, because the feedback usually is that our students are amazingly capable of starting right away, work in a team, and bring results because they're already used to it through doing these projects. We try to simulate, especially in the game course, the real world. What you see here are some photos of our students working on a real world project. We always have these live projects, one a year, where our students work as a development team based on the different specializations and combine their skills to build an actual game or interactive media product prototype for an actual client. They have to deal with the client, they have to pitch their ideas to the client, they have to schedule their work, write the game design documents, change the game design documents, and then do the work on the actual product and hand it in by the end of October. This obviously helps a lot with the whole aspect of learning and getting work experience before you actually start in the working world. They apply their knowledge, they learn from each other, they learn from their mistakes, and they realize that planning and the real world sometimes do not go well together. Yeah? But this is an essential part of our students' learning experience when they are at the Academy of Digital Arts. And of course, our lecturers mentor them, guide them, and are there for feedback and guidance. One of the biggest live projects we've ever done was the EasyCom Museum project here at the Cape Tonian Slave Lodge, where our students created the first ever augmented reality enhanced diorama for a museum in South Africa. And that was an official project for the EasyCom Museum, done by students that had never done something like that before. And they made it work, and it's now a permanent exhibit at the EasyCom Museum Slave Lodge. By the way, the graphic design students were part of that project. Their part of the live project was actually the rebranding and redesign of the entire Egyptian part of the lodge where this exhibit can be seen. And then at the end of the year, the portfolio of your work through all the projects, the final exam projects that proves your special skills and your specialization and the level of specialization you've reached, will be used at the graduate showcase, which everything works towards. At the end of November, we have the graduate showcase. We invite industry people, we invite the public, we invite the parents. Last year we had about 450 guests, and our students show their work. This is our students' evening where they can show their work, they can talk to industry people and make contact, network, and it usually leads to the first invitations to job interviews, paid internships, and well, have just celebrating the level of knowledge that and skill that our students have gained. So this is the presentation part about the course. I hope it didn't take too long. There's a lot of ground to cover, but I want to go over a couple of frequently asked questions quickly that usually come up in the real world open day presentations that we do. If you have any other questions than the one that I cover right now, please send an email to lars@ada.ac.za and I'll get back to you as soon as I can. One of the most frequent questions is, does a student need a laptop or a workstation at home? It's highly recommended. However, you do not need the latest high-end gaming PC. A standard laptop for around 12 to 14,000 Rand, Windows based. Mac works too, but if you want to go into 3D, you should definitely go for a PC, because Macs cannot handle the 3D and real-time 3D graphics anymore. At least not as well as the Macs, as the PCs do. A standard PC is definitely enough. Just make sure that it has 8 GB RAM or more and a halfway decent graphics card. If you need any specs, please drop me an email. I'll get back to you as soon as I can. Our students can work in student labs, but it's very beneficial if you can sometimes catch up from home or exercise something that you're passionate about a little bit more without being at school. Do you need to bring any knowledge? No. We start all our modules, including the programming, from scratch. Like really from the get-go. You do not need to bring any knowledge. The only thing that you should bring is essential knowledge in Photoshop. And even that you can learn through one of our online courses, which we offer for free once you've enrolled in the course. If you bring knowledge, even better. If you bring knowledge, we can take that and push you even further. Yeah? In some cases, some of the students already have some programming knowledge, then they have it a little bit easier in the programming modules, and they can focus a little bit more on the 3D modeling part, for instance, where they might have a little bit of a harder time, so they can invest more time there to push a little bit harder and get to the same level as others that already have some knowledge in that field. So there is no real downside if you do not bring any knowledge whatsoever. Everything can be learned. The other question that usually comes up is about the interviews and the portfolio. At Friends of Design and the Academy of Digital Arts, we are not focused on your marks. There is no, you have to have a certain degree in mathematics or computer sciences. A general understanding of how a computer works is definitely a must, but that is a must in pretty much every job today. What we are looking for are students that show us that they are interested in being creative, whether it's visual or in terms of programming. They want to solve problems. They want to tackle a problem, they want to solve them. So that means they want to put effort into something. We are looking for students not necessarily that are only talented. If you're not talented, but you put in a lot of effort into learning, then you will be very likely a more successful person in the workplace later on than somebody that is used to everything coming to them easily, and when they get into trouble they lose the courage to go on. So the most important part is actually the interview. In the portfolio, if you've done Let's Play videos about games and analyzed games, that's fine, bring those. If you've created a level, if you've done something already in a 3D modeling tool like Blender, or you've created a small game in the Game Maker, doesn't matter. Just bring it. And then we will have an interview, because I'm more interested in who you are as a person, why you want to do this, why you want to do this at Friends of Design and all of those things. Because to me it's more important that you're driven and motivated than knowing everything already. That is our job. And if you know everything already, we cannot teach you anything. That makes our job even more boring. So don't worry too much about the marks. Good marks are always beneficial, but they're not a neck breaker if you show a lot of effort, drive, and talent. So send us your application with the submission forms and the submission questions, and then we'll invite you to an interview and we'll see how we fit together, if we fit together. I hope that answers all your questions. If I haven't covered something that you have questions about, as I said earlier, please drop me an email. And I hope you enjoyed this and you have a clearer idea what the game course and the game development and technology and interactive media career is about. And hopefully I'll see you soon for an interview, and next year in February in class. Thank you so much for your time.